It's time. Let's get started. Thank you all for joining me. This is day 2 of droidCon. We've had 3 talks about instant apps, a couple of talks about refactoring code. So I'm very happy to have an audience here still, because this is yet another talk about instant apps. On the other hand, this talk will be different. We've taken a different approach, and I'd like to share what we've done there. I'm Eric. I'm the CTO at GuardSquare, the company that I founded. And at GuardSquare, we develop the open source project, ProGuard, that you may all know, love to hate. ProGuard takes bytecode, makes it smaller by removing unused classes, fields, and methods, optimizes it by, for instance, inlining methods, propagating constants, and also makes it a little bit harder to reverse engineer by obfuscating the names of the classes and the fields and the methods. On the other hand, we also developed DexGuard, which is the commercial product that we sell. And DexGuard does the same thing essentially, but it applies this to an entire Android APK. So it can not only processes the bytecode, but it also processes the resources, asset files, resource files, native libraries in an APK file. And it focuses on hardening applications against reverse engineering and tampering. Now, I've been working on ProGuard for many years now, and I'm still very proud of it, so I'll mention it whenever I can. And this presentation is no exception. But the good news is that it's relevant, so you'll see that it pops up in a number of places where it's actually useful. So let me get started. And this is the wrong slide somehow. It's the wrong presentation even. Give me a few minutes, I'll have to get to the right presentation. So in the presentation, I'll start with a general overview, the kind of overview that you've seen in the presentations in the past few days, and the information that you can also find in the general documentation for instant apps. So because you've probably seen most of that already, you're probably a bit familiar with that, I'll try to go through that rapidly. And then I'll come to the interesting stuff, the stuff that we've done, that we've created. And in that, we've also processed a number of open source projects to create 25 instant apps. And from that, I'll share the experience that we had, the observations that we made, the problems that we encountered there, and that may be useful for your own implementation if you ever write an instant app yourself. So I'll try to go to the slides now. Thanks, Jake. Yeah, so that's the overview. It looks a bit academic, but I'll get to some practical results near the end. First of all, an introduction to instant apps. The structure is somewhat different from a typical installed app that you create. There you have a monolithic code base, a single set of classes, and resources and asset files that all go into a single APK file. With instant apps, the goal is to split up this code base into several features, as they are called. Each feature contains some useful activity, typically, one or more activities, which are addressed through URLs. So instead of downloading your app from the applications from the Google Play Store, you can now browse through the web to a certain URL, and your feature will be downloaded lazily from the Google Play Store. And then as you move through your application, you can jump to other URLs, and other features will be downloaded lazily. So that's the basic concept. Now, to make this a bit more practical, it's possible for features to share code, and this is what is put in what they call a base feature. So this is some sort of shared library in the application. Let's see, what else is there to be said? Well, this is something that you see at two levels, really. On the one hand, there's this subdivision at the source code level, the level of your project in Android Studio. And on the other hand, there's this structure in the output of that build, where you'll have corresponding APK files for each of the features. And the result is then typically zipped up in a single zip file and uploaded to the Google Play Store, where it can be used by your end users. So how do you typically start an Android instant app? How do you typically start developing it? Well, the Android Studio provides a wizard to create projects, and that wizard has a checkbox that allows you to indicate that you want to create an instant app project. So that's a very easy way to start, because then the Android Studio will set up your project, and you can start building from there. And because we're interested in the internals, I'll start by looking at the input that you create in your project, and then move on to the output that comes out of that. And I'll go over it quite rapidly. It's something that you can also find in the documentation. So your project will then contain several modules, each corresponding to a feature of your instant app. There's the base module corresponding to the base feature, and it's fairly standard. It contains a build file, it contains an Android manifest file, source files, asset files, and so on. And similarly for features that are built on top of that library. There's also an almost empty module in the project then, which is the instant app module. And I'll show in a bit more detail what these modules contain. If you look at the base module, it contains this build file and the Android manifest file. The build file is pretty much like a library build file, except that instead of using the library plugin, it uses a feature plugin, which is new. And there is an indication that this is a base feature, so a feature that contains code and resources that can be used by all the features that build on it. It also specifies the feature that depend on it. And the Android manifest, on the other hand, is almost empty, because all of the activities that will go in your application will be specified in the actual features. Looking at one of those features, a feature module, it also contains a build file, it also contains an Android manifest file. You also apply the feature plugin there, and in this case you have to indicate that this feature depends on the base plugin, because it wants to make use of all of the code and resources that are there. And the activities of this feature are specified in the Android manifest file. What's a bit different from usual activities is that they specify a URL to access that activity. So by going to that URL, your activity will be possibly downloaded and launched. In addition to the changes in the build file and the changes in the Android manifest file, there will also be some changes in the code of your application. And most notably, when you create an intent to go from one activity to another activity, instead of specifying the class of that other activity, you'll specify the URL to go there. So there are all these small changes in the code and the Android manifest and in the build file, but nothing too serious. It's still manageable. If we look at the final module that you'll have in your project, this is the instant app module. It applies the instant app plugin, and this is the one that ties together all of the other modules in the project. It specifies all of the features that you want in your instant app application. So in conclusion here, there's not that great a difference between a standard Android project and an instant app project. It's just that you'll have typically more modules, and each of these modules contains files with slight differences from what you're used to seeing, but it's not that dramatic. It's just there is a bit of ceremony about it. And of course, at that point, you'll have to start developing these individual features, and you'll have to make sure that they remain independent and only build on the base feature. Now, we're more interested in the deeper technical details. So we'll have a look at the output that comes out of this. If you build your project in Android Studio, it will launch Gradle and all of the Android tools, and they do all of their magic, and you'll get your APK files out of it, your Instant App APK files. And looking at those APK files, looking at the contents, they contain compiled files, compiled Android manifests. But having a peek inside there, you can see that they're essentially the same as traditional files, but they contain slight indications that it's about, in this case, for instance, a base APK. Or in the case of a feature APK, there are some other elements and tags that indicate that it's a feature APK, and that that's the way Android and the Google Play Store can tie everything together. And going into even more detail, your feature APKs will also contain those resources and the R constants that you have in your application. You may have noticed at some point that they typically start with 0x7f and then some number as a numeric identifier of resources. Well, that's still true for the base APK, but if you look in the feature APKs, they'll start with 0x80 or 0x81, and this is to allow these different feature APKs to be combined together in a single process without the resources clashing. So again, it's pretty much like a standard APK, but there are tiny differences in various places. At that point, you'll probably want to launch your Instant App. You'll probably do that by clicking the play button or some Android task, some Gradle build task. Or you can upload your Instant App to the Play Store and test it from there. There is a somewhat undocumented feature of ADB that allows you to install all of the Instant App feature APKs all at once, and then you can launch it through ADB shell AM to sending an intent to that Instant App. It's something that we found very convenient, just to be able to launch and install and launch applications very quickly. In practice, this will lead to some sort of hybrid situation where all of the APK files are uploaded and installed and run at the same time. But we found it very useful for testing. Okay, so at that point, we've created a new Instant App. But what if you want to refactor an existing project? And this is a situation that most of you will be in, where you already have an application and you want to create an Instant App version of that. Well, you'll have to start refactoring the code. So you start from your original project. It contains all of the elements that go into an application to create an installed app. But you'll need to refactor it, just like when you create a new project, into all of these modules in Android Studio. And you'll have to adapt all of the build files. You'll have to adapt all of the Android manifests. You'll have to adapt all of the code that creates intents, for instance. And then at that point, you can also build your application. You can still build an installed app, but you can also build your instant app at that point. There's nothing spectacular about it, except that it may be a little bit of a daunting task if you have a huge code base. It feels a bit like playing a game of SimCity, where you have to move around resources to get your app running properly, or to get your app split and built properly. If it works well, then it's fantastic. If it doesn't work, then it's chaos and frustration. Another small note here, there are some artificial constraints that are imposed on instant apps. So on the one hand, you have to make sure that things just work. On the other hand, you also have to take into account these constraints, and you've probably come across them before. For security reasons, these are the artificial constraints that you can only use the following permissions. They're all documented, and you have to use them dynamically. And on the other hand, you have to make sure that your app is below a certain maximum size. And size in this context means the size of your base APK plus the largest size, or the size of your largest feature APK. That's the limit that the Google Play Store will, in practice, impose. Now, there are a couple of things you can do about this. Of course, you need to identify which functionality you want in your app, especially if you have a large app, you'll have to cut a little bit. But on the other hand, there are some things that you can do automatically, and this leads us to ProGuard accidentally. You can enable minification in your project to enable each of the individual features. And this is worth noting that ProGuard and the minification is applied to each of the individual features and to the base feature. So you can shrink, optimize, and obfuscate that code. But that leads to an important constraint because it's done on the individual modules, namely that you need to make sure that all of the public API that is used by the features is still present in the processed base APK. So that limits what you can do there, and that is suboptimal in a sense. You can't obfuscate all that much, you can't shrink all that much because the features depend on the functionality being there, if only to compile and then to run also. Also something worth noting that if you have external libraries, they'll typically go into the base feature because they'll typically be shared, in many cases at least. And they're also quite monolithic, so they won't be shrunk or optimized very effectively. As a small digression, this seems like a good occasion to mention that ProGuard 6 is out now. And it contains support for Java 9, it contains new optimizations, but listening to the feedback that I got from conferences, many of you have problems setting up a ProGuard configuration, and yeah, the setting up is the hardest part. There is a bit of a learning curve and a bit of a time that you need to set up a configuration. So we've added an option, add configuration debugging, that will instrument your application so that at runtime you get feedback on the configuration that you've created. And then ProGuard or your application will print out a message in the logcat. ProGuard is always very polite. And then it will provide an actual configuration setting that you can just copy-paste in your ProGuard configuration file. So I personally have found this very useful to work with code that I didn't know that well, external libraries, for instance. Another option that's new is an option called if, and just to make a long story short, this will help you a lot to create a configuration for Dagger. So Jake has successfully lobbied to include this in ProGuard, and it's there in this new release. So it allows you to keep module adapter classes, for instance, and their corresponding base classes, so that Dagger's reflection can still make sense of the resulting code. Back to instant apps then. So as I've mentioned, there is a whole process to create or to convert your installed app project into an instant app project. And we thought that was a bit daunting and quite a bit of work. We've done it a few times, but we thought that could be improved on. And we've taken a step back and looked at what the problem really is there. And the problem is not so much adapting the build files and the Android manifest and the code, but most of the problem lies in finding all of these dependencies and splitting your project into these separate modules. So if you look at your application, it contains classes, say. Let's say the blue dots are classes, but also resources. So the classes may point to other classes and they may point to resources. The resources may point to resource files, like layout files. Layout files may point to other classes again. So there is this whole graph of dependencies between your classes, resources, resource files, asset files, and so on. So what you actually want to do is look at what an activity needs to run. And the solution is simply perform a transitive dependence analysis. And that's what you can do like this. That's what it would look like. If you have a certain activity, it depends on all of these other elements. And that means that you need these elements if you want to run that activity. And you can do that actually for all of the activities. And at that point, the results of this analysis can be used to determine what can go into separate modules, into separate features, and what needs to go into the base feature. So that's indicated like this. So the gray parts, light gray parts, can go into their own features, in their own feature APKs. And the dark gray part needs to go in the base feature because it's being shared by one or more, or two or more features. Now, this is a process that you already do mentally if you start splitting your project into several submodules. But actually, it seems like a quite mundane task, quite a mechanical task, and a computer could do that way more effectively. And there are tools that can do such a dependence analysis. And again, coincidentally, a tool like that would be ProGuard. ProGuard already does a dependence analysis to determine which code is necessary in your application and which code can just be thrown away. And we've used that concept here. Except there is a small thing here. ProGuard just looks at the bytecode. It doesn't look at the resources, asset files. So we've actually built on DexGuard in this case, which can perform the dependence analysis for an entire Android application. So that's the process that we've come to. We've created this implementation on top of DexGuard to automate all of that. So you can start from a standard Android project. You go through your build process. You can build a standard installed APK, but you can also build an instant APK or a set of instant APK files. And in that process, there will be this dependence analysis, there will be shrinking, optimization, obfuscation, and also the partitioning into these APK files. So that's a lot more attractive, and you can already imagine that it's more effective also because the automatic analysis can do this at a way finer level of detail than you can do in your source code, especially if you consider monolithic libraries, for instance, that you couldn't split in your source code. And it will also be done at build time in just a couple of seconds. And every app will therefore be optimally split into feature APKs. So that seems a lot more pleasant. And to make it a bit more tangible, this is what it looks like in our implementation. So there is a build file that contains, that refers to ProGuard files, or in this case, some DexGuard files. And it could be any type of build file, really. So this also works with Ant or Maven or Eclipse even, anything you want. You can even work from build APKs if you wish. But the essential part is in the ProGuard or DexGuard file, where you can specify the features that you're interested in. They all have a name, they refer to an activity in the application, and each of these activities corresponds to a URL. And then our implementation will just go about the build process. It will modify the code, the Android manifest, and so on. And most importantly, it will split everything into the specified features. So yeah, these are the advantages that I already mentioned. So at that point, we had a new toy, so we had to play with it. And to do that, we downloaded 25 open source projects quite randomly. I think these are the ones. The largest one is Firefox, which is 37 megabytes, I think. My favorite one is the Frozen Bubble game, because it builds in a minute, and then you can spend an hour testing to make sure that the high score feature still works. So we've created instant apps for all of these applications. Or actually, to be honest, we've asked our intern Laura to do this for us. She didn't have any prior Android experience, but she pulled this off quite successfully. And I tried to summarize the results of this experiment in a single graph. On the left-hand side, each time, the dark gray bar is the initial size of the installed app, and the light gray bar is the size of the instant app. So the maximum size that I showed earlier. And the light gray bar is smaller, in part because there's this shrinking, and in part because there's the partitioning into several smaller APK files. So at this point, we didn't take into account any of the constraints of the permissions that you can use and the maximum size. As you can see, some of the applications are still too large to fit into an instant app. So there's no magic there. You can't force any application below the 4 megabyte limit. So at some point, you'll have to make sure that you use the right permissions in your code, and you'll have to make sure that you reduce the functionality such that it does fit eventually. But for some applications, it was quite successful. They started out with a larger size than 4 megabytes, but in the end, they were of an acceptable size. I'll go into a few more details of some things that we saw that were quite typical for many of the apps. So let's see, how can you further improve on that? So what are the things that you can still do manually or with some help of our implementation? First of all, looking at the Frozen Bubble app, it's actually a nice game, but also a nice implementation. So it behaves very nicely if you split it up in the 4 activities that it has into 4 features. The largest feature is the actual game itself. The smallest feature is the preferences screen, which is very small. And you can immediately see here that the game is still too large, but then you can quickly identify what the problem is. Looking into the APK file, it actually turns out that most of the size there is taken up by music files inside the game. So just by removing a couple of music files, you can quite easily get below the 4 megabyte limit and have an instant app version of that game. Then we also looked at the IoSched app, which is a very typical app for this sort of experiment. And it shows a completely different pattern. There is a very large base APK, and the individual feature APKs are, again, insignificantly small almost. That's because there are 16 activities, and we've created a feature for all of them, for each of them. Now, we wanted to figure out why this is, because this doesn't feel quite right. The size is below 3 megabytes, but it doesn't seem quite right that the base APK is so large and contains all of the code. And what we noticed there is a typical pattern where you can have 2 features, and they share, they're almost overlapping in all of the code that they share. So they have a huge overlap in the common part. And to solve that, you can try to pull them apart, but an easier solution then is to just put those 2 activities into a single feature, so that these features can take up their own APK, and the base feature becomes a lot smaller. And I've done a quick experiment with that. I've put all of the IoSched app in a single feature, except for the map activity of that app. And you can already see that there is a slightly better balance between the base APK size and the feature APK size. Another observation that we saw in a number of applications, if some of your activities depend on a parent activity, that dependency results in pushing that main activity, in this case, into the base APK. So that's not ideal. You'd ideally want that main activity in its own feature, but using the parent activity name will result in that being pushed in the base APK. So this is a pattern that you'd probably want to avoid if you create your own instant app. Another thing that we saw in a number of applications is the God class, where a single class contains references to all of the activities in the application. And that, of course, pushes all of these activities in the base APK, because all of a sudden they are shared among all of the code. And that's something you certainly want to avoid. It's not something that we do automatically, so you'll have to do some manual refactoring in such cases. And as a final example, it's a bit similar. What we sometimes saw in a number of applications is where each activity class contains a utility method to create the intent that corresponds to that activity class. Now, if other activities start referring to that utility method, again, that pushes that activity class and all of its dependencies into the base APK. So this is something you'd like to avoid also. And this is such a common pattern that we saw that we automated that. So our implementation refactors the code, pulling out such a static method into its own class, tearing apart all of these dependencies. So that is solved at that point. Okay, so that leads me to some final conclusions. As I've talked about instant apps, the way you usually do it, there is some work involved there. You need to adapt code, manifest, and most importantly, you need to perform this dependence analysis and refactor your code into modules. We're a bit lazy, so we try to avoid that. And we created instant apps. That means they are instant to end users, but they're now also instant to developers. With just a few lines of configurations, as you could see, you can create your own instant app. And as I've argued, this is easy and quick to set up. It's flexible to experiment with, as shown in our tests. And it's also optimal, because in each build, that analysis is redone and you get the optimal partitioning for your project at that time. Let's see, I'm biased, of course, but in my opinion, this is the future of instant apps. This is how it should be. It should be easy for developers also, so that they can get their instant app out and do more useful stuff, or at least more fun stuff, perhaps. So that concludes my talk. Thanks for being here, and thanks for listening. So I've had help from my team, a number of engineers and interns. And if there are any questions, we still have some time.
Thanks for the talk. One question, some of what you showed reminded me of the de-spaghettifying talk that was given by Square yesterday.
Yeah.
Have you considered using this tool for modularization instead of, if you don't care about shipping instant apps for your app, but you still want to modularize for build time and just better architecture, do you think your tool could be used for that?
This implementation works on the bytecode, so on the compiled version of your application, also where it's already optimized, so it might not even be recognizable. And it's you could take that back to your source code and start refactoring your source code based on that, but that wasn't our goal. Of course, Android Studio contains many wizards already to refactor your code, and I think they're way more effective and human-friendly than this implementation for that purpose. Yeah. Also, this is still complementary to, of course, de-spaghettifying your code. You probably want to do that anyway, and you'll get better results in the automatic approach as well if you've done that. Okay. Yeah.
So this looks really appealing, and I agree with you that it looks like this is the way that instant apps should have been implemented from the start. One of the things that I noticed was you mentioned this as a part of DexGuard, not ProGuard.
Yeah.
And And I also saw that it was patent pending up on the up on the top of the slide. So at the DexGuard site, there's no pricing information. You have to contact to get a quote.
Yeah.
So is this something that's really feasible for non-enterprise developers, or do you have anything you can say about pricing?
Yeah, this is outside my area, of course. So from a technological point of view, we had to build on top of DexGuard. So right now it's a free addition to the commercial product. The pricing tries to be fair and reasonable by it's based on the number of end users that your app has. So it's less for small individual developers, and it can be a lot more for huge enterprise customers. But I don't even know the details of that. So you'll have to talk to my colleagues who are also here at the booth, and they have a booth. Yeah, talk to them. Yeah.
So you showed on the screen with the class dependency graph of, thanks. You showed on the screen the class dependency graph of you have activity A and activity B, and these are all the classes they transitively depend on. One of the things I've struggled with modularity projects like this is kind of a minimum cuts algorithm to, if I want to improve the modularity of it. So, say my class transitively depends on 500 classes, but if I cut out 3 references, it will only do about 40.
Yeah.
Does ProGuard or DexGuard offer any sort of heuristics or advice of like, hey, you could remove this and then cut out a ton of dependencies?
Yeah. There's nothing like that at this time. So that's a very interesting problem. So you'd like to automate that to some extent. We are trying to help a little bit with the static method that I mentioned, but there's no high-level analysis of where you could cut. Another interesting problem would be how you could combine activities into certain features so that you get an optimal combination and an optimal balance between the base APK and the individual feature APKs. So those are interesting problems, and we don't have a solution for that yet. Any other questions? Okay, that'll be it for now. I'll be around if you come up with anything new. Thanks.